The main projects that Renault got involved in through Project Pit Lane were many and to varying degrees, but in no particular order. We had several ventilators, SAGENTIA, Smiths, PENLON, BLUESKY, and then there were other pieces of work to do with protective equipment like Oxbox and even medical communication device, COVICOM. So we coordinated the support for each stream really in a very flexible and informal way. It certainly wasn't terribly rigorous. It was a process really of taking each of the requests that came to us and identifying who would be the best group of people to be able to take that on. So the BLUESKY ventilator came to us through Innovate UK, and one of their young entrepreneur medical engineers had a concept for a low-cost ventilator that sat somewhere between the sort of bottom-end CPAP devices and the very high-end, more expensive, sophisticated machines like the Smiths device or the PENLON device. So there was at the time of the start of the crisis a real need for something that sat somewhere between those two extremes. So we were asked to take a look at the project, the concept, and see whether or not we could engineer it up to production level, which we did, and assessed that yes, it could be done in a short space of time, and even to the extent of producing production quantities of the device. So the government supported what we proposed to do. They provided the funding. We hooked up with a medical equipment manufacturer to provide the support we needed for all the regulatory side of things, and then together we set off. So BLUESKY was a real collaborative effort between several teams. So Red Bull, Renault, McLaren, Mercedes, Haas, and we basically tried to divide the work up to suit the strengths of the individual teams. So Renault looked after the electronics and control system design. Red Bull looked after the mechanical design. Mercedes did a lot of manufacturing of test equipment and development of the test equipment. McLaren supported on electronics, and Haas supported on risk analysis and support on control systems. So it was a good divide, and as I said, it played well into the team's individual strengths. The departments within Renault that supported the BLUESKY project were several. Probably principal amongst those were the electronics department under Jason Rees and the control systems department under John McColgan. And they worked exceptional hours to deliver on that aspect of the project. It was complex, difficult work. But there was also fantastic support from other groups, from production planning, because there was a lot of organisation, management of suppliers and planning of the whole project. So we had great support from those guys, from the purchasing guys as well, and from the production guys and the race team guys, who got very heavily involved towards the end as we set up a production line to potentially produce devices in large quantities, both here and at Red Bull. So the PENLON ventilator was, I believe, an existing design of ventilator made by a relatively local company in Abington. And the F1 community was asked to support that in various ways. It was also supported by a combination of larger UK industrials, basically to upscale production, because it was very much a cottage industry, and now it needed to go into serious mass production. So some of the big UK industrials got involved to do that, and I believe that at least one of the F1 teams helped in some of the engineering to make that happen. But the bulk of the support that the F1 world through Project Pit Lane gave was to provide an army of testers who would test these devices as they came off the production line to make sure that they were fully functional before being shipped off. So ourselves, Mercedes, Racing Point, Williams, we all provided tens of people. I think in the case of Renault, it was probably 80 people, something like that, that went onto a shift system to provide the end-of-line testing capability.
I volunteered to help out just because I wanted to do something in such an awful situation that the COVID-19 pandemic's been for everyone. I wanted to help out in some way, so that's why I volunteered. My role at PENLON was night shift manager. I thought I'd be there just testing them, but ended up managing the whole shift. So supporting my colleagues, answering queries, solving problems, and really just managing the flow of ventilators on our shift to get as many out to the NHS as possible.
Another project that came our way through Project Pit Lane was support for a ventilator that was being developed by a company called SAGENTIA. And we weren't actually involved in the ventilator itself, but it's a good example of where some seemingly less important things can be critical to the success of the overall concept. And in this instance, it was the trolleys that hold the ventilator so that it can be wheeled around hospital wards. And we were asked whether we could take a rough concept for a trolley and re-engineer it and design it in a way so that it could be made in quantity quickly and easily. So we did that. A couple of the design engineers from within Renault did that in a matter of a couple of days. The design was passed down to our fabrication department. Those guys managed to produce something like 4 or 5 prototype trolleys in the space of, again, 2 or 3 days. And they went off to SAGENTIA, and as far as I'm aware, they were used. I don't know what happened in the end with the SAGENTIA project, how many devices were produced in the end, but at least they had the design for a fully functional trolley should they want to make it in large quantities. It again is another story that speaks of the strengths of what F1 can bring to these sorts of projects, and that really is our ability to be able to react quickly to a design challenge, and then to be able to find a solution that can be made quickly and, if necessary, in quantity. And that's exactly what was required at that point in the crisis. There is a device called COVICOM, which we're now working on, and that's a working title for the minute. That could well change. But this device, again, is very simple in concept. And one of the big problems that clinicians face when they're dressed in full PPE, when trying to work with patients or even communicate with one another, is the fact that it's very hard to be heard because the PPE suppresses the sound of their voices and restricts what they can hear. A clinician at Leicester University Hospital came up with the idea of using a small voice amplifier that could be clipped to a belt in which you could hear through an earpiece and speak through a microphone, and your voice would be amplified, and patients would be able to hear you more clearly, and your colleagues would be able to hear you more clearly. But also one of the other problems that clinicians face in terms of communication is the fact that they often need to have delicate conversations with relatives and so on through mobile phones. And of course, that's a really difficult thing to do in PPE. And sometimes they have to do the same thing, but through the hospital phone system, which again is difficult to do. So they came to us and asked if we could assist to help develop a device that would satisfy those requirements. And so we agreed to take that on. So Project Pit Lane is working to develop such a device. We have applied for government funding to see that work through to the point where we will have produced fully functional pre-production prototypes that could then go into mass production. And again, that is largely being led by Renault. It's predominantly an electrical design challenge. So Jason Rees, who is our former head of electronics here at Renault, is leading the charge on that one, ably supported by some of our mechanical designers here for all the packaging and casework that needs to be done for it. So yeah, we're very hopeful that that device will go through into production, will be successful, and will actually have quite long-lasting legs, because it's becoming clear that the problems that clinicians face with full PPE isn't just for when they're dealing with COVID patients. Any routine operation now, they have to use full PPE. So this problem is going to be around for some time, and hopefully this will make life a little bit more tolerable for them. So Project Pit Lane also came across another interesting requirement that in fact at one point became very critical for the NHS, and that was renal filtration fluid. At one stage during the COVID crisis in the UK, it was becoming clear that a lot of patients who required ventilation were suffering kidney damage as a result of the disease. And there was a pressing need to provide what's known as renal filtration, which is basically flushing a cocktail of chemicals through the kidneys to keep them functioning correctly. And there was a real concern there might actually be a shortage of this fluid and indeed the devices to pump it around the body in the UK for a short period of time. And so we were asked whether we might be able to help on the rapid development of the actual devices that pump the fluid around and do the filtration. So we took a look at that and deemed that it was probably outside our area of expertise to be able to do it in the time required. But the need stood for the fluid itself that's used. The NHS felt it could probably cope with the equipment it had, it just may not have enough fluid. Again, the chemistry of these fluids is probably outside the expertise of individual Formula 1 teams. But we've got some fantastic partners. In the case of Renault, one of our biggest is BP, who know a lot about chemicals and the mass production of them. So we spoke to them and they were fantastic. They instantly jumped on it, came on board and worked with us and the NHS to define what their requirements for these fluids were and to offer to help source them from around the globe through their own supply chain, and even potentially set up a production facility in the UK in a very short space of time. Thankfully, that crisis was very short-lived. It passed and the need went away. So that project, thankfully, wasn't required in the end. But it did show a great sense of spirit and cooperation between the NHS, between one of the large industrials in the UK, BP, who is one of our partners, and ourselves to try and help that problem should it be needed. So the Oxford box came our way because Project Pit Lane had some contact with a consortium of smallish companies based around Silverstone, and they were doing independently work to help the NHS. They were doing some ventilator work. They were also doing a lot of work to help procure PPE and manufacture PPE. So we had some contact with them, and through them we were put in touch with two people who were sort of behind the Oxford Box project, Christiana Pace and Ron Hartfelt. And they had worked with clinicians at Oxford University Hospital to develop a protective shield to put over a patient's upper body and head with access holes that would allow clinicians to carry out procedures on the patient while protecting themselves should the patient cough and exhale aerosol virus. And it's a very, very simple concept, which is always good. It's basically a clip-together perspex box. And despite its simplicity, it does require some relatively smart thinking to make sure that it functions and that the aerosol virus doesn't escape. And so they contacted us and asked if we could help do some computational fluid dynamic analysis, which is basically a way of determining how gases and particulate in gases move. And we're very experienced in the world of F1 at doing that because we use it to design our cars day in and day out. And our head of CFD, Paul Custin, rose to the challenge and agreed to help them with this analysis to prove that the box would contain the aerosol-borne virus. And say that was a very successful and quite a novel piece of work in the end.
So Renault first became involved in the Oxford box when we were approached by Innovation and One Design Engineering. So CFD benefited the design of the Oxford box really just by examining small design improvements that might be made. For example, should the lip at the front of the box be a little bit bigger, a little bit deeper, or should the fitment of the panels be a little bit better? Also, as well as just some small design improvements, we also use it to analyse the overall effect of the box in the first place. So for example, what percentage of cough particles would have ended up over the healthcare worker without the box, and what percentage of cough particles would end up over the healthcare worker when the box is in place. So Formula 1 modelling is all about the airflow itself, whereas with the Oxford box we're interested in injecting particles into the airflow. So the basis of both simulations is actually very similar. There's just a small addition for the Oxford box by actually tracking those particles, working out where they travel while they're active, and also where they settle. So when they come to rest on a surface, what surface have they come to rest on, and how might that pose a danger to the healthcare workers? So the Main advantage of involving F1 in a project like this is really to try and compress the timelines. So our systems are set up to react fairly quickly, perhaps even something that might have happened over a race weekend. We will need to perform that simulation within a couple of days to ensure that should we have picked up something on Friday testing, for example, it's fixed by the race on Sunday. So that sort of experience and expertise really helps us out for a project like this, which of course was being done in the midst of a worldwide pandemic.
The MAKAIR project was a project launched by a few individuals during March that actually were thinking about what can we do in this situation, with this crisis situation, to help around us, to help the people. And they actually decided to go on to trying and making a respirator, and that all started from there. Basically, Renault Sport Racing gets involved into this MAKAIR project because after days or a couple of weeks, there was more and more people involved in that project, and alongside we, Renault Sport Racing and Renault were actually involved in dealing with APHP, which is the consortium of hospitals in Région Île-de-France in Paris, and we got actually linked with some of the projects around the respirator, and we found out that the MAKAIR project was quite a good project, a challenging project, and we actually decided to focus on that project. Firstly, because that project needed some specificity and especially a blower that was missing at that time of the year, and especially in that crisis, and we just get things started by then. During this project, Renault did actually a big variety of things, as basically started with making a blower out of nothing. Basically, in a respirator, we need to generate some air, and at that time of the year, when we looked around and tried to actually get a supplier to supply us with blowers, there was nothing around because of the actual situation. We decided to create from scratch a blower, which is actually a small compressor that looks like a turbo compressor when we look at a Formula.1 engine, and we had to link that to an electrical motor. So we did all of this through a design that was purely 3D printed, so that it's easier for anyone around the world to make it happen. And from there, we actually linked and get involved into the project by going on site where all the people from the MAKAIR project were, and we find out that we could help on actually getting things done in terms of design. So we actually drawn all the parts of the first version of their respirator, and then when we basically understood everything that was needed from a respirator, whether it was from the doctors or the people in place there, we could think about, okay, how do we make a respirator that could be made 1,000 parts a week? And we get on this project with the Renault guys, so Renault and Renault Sport, where we were doing the design, and at the same time we were looking at how we could actually produce them, and that's basically led us to redesign a second version of the hardware that was easier to produce, and at the same time we also thought, okay, now we need also to develop the software, because there is a lot of intelligence in the software, which we did, so that we can actually have a respirator all in all, hardware and software, that could be made available to anyone in open source. So that was a work of something like 2 months, and we're now to a point that it's working and it's available. When we look back to this project, I guess we can get a lot of satisfaction out of this kind of project. First, because we could be at a time of the year very critical to the situation, because we could actually work out a project that was a good help for a lot of people. So this is the first point. The second point is we could clearly see there was a lot of people in our company that were involved around this project. Actually, we had to say no to some of the people, and unfortunately, but we had a very good group of people motivated, and that was a sort of a race that we did over 2 months. In F1, there was no races done at that time of the year. We were just shut down, and I think we've taken that as a race for life. and we actually made everything we could and maybe more to provide that respirator that we can now touch. 2 months ago there was nothing like this. It's there, it's working, and I think we can be proud of that, because all the people that put the energy into it were just incredible. That's the story of maybe it's a journey of 2 years normally to produce that kind of thing, and at the same time we can be proud of us to have helped people outside, to have helped the world, and I don't think we can say we won that race. The race is still going on, and I think we're going to keep on providing help to that cause, and I think at the same time we were able also to show outside, to show to our people, to show to our company Renault what we could be achieving in Renault Sport Racing, not only Formula 1 but everything that we at some point decide to get on with, and I think that's maybe the greatest achievement.